Section 2.2, example 7, solving a rational equation with factor denominators and stating the excluded values. So we're going to solve this problem after factoring the denominators. And let's see what we have to do and state excluded values. So again, like I said in the previous video, we do not want the denominators to ever equal 0. So what we do is we could state each of these equaling 0. And that way we could see what we're not going to let these equal. All right, so if that confuses you, we could just use a does not equal sign. So starting off with that first fraction, our x plus 1. X plus 1 cannot equal 0. So subtract 1 from both sides. X cannot equal -1. And looking at this one here, x minus 1 equals or cannot equal 0. Add 1 to both sides. X does not equal 1. And the very last one, x squared minus 1 equals 0. X squared minus 1 does not equal 0. Add 1 to both sides. X squared does not equal 1. Take the square root of both sides. X does not equal. Here, there's a possibility that whatever we have in here was a negative number, that when we squared it, it turned into a positive number because negative times negative gives us positive. So when we take the square root of square numbers, we have to give it the option of it being plus or minus. So either the positive version or the negative version. So in this case, x cannot equal positive or -1. So it looks like we have similar solutions for these. So x cannot equal -1, x cannot equal +1, and x cannot equal negative or +1. So that kind of tells us right away that we have some similarities here. So now that we have our excluded values, so x cannot equal 1, -1, or 1 or -1. Okay, so our LCD, this one here is already factored, or it's a binomial. This one here is a binomial already factored. We can't factor it anymore. But this one here is not, or we could call these prime because we can't factor them anymore. Those are prime. This could be factored. So that, let's get into a little recap of difference of squares. So difference of squares. So difference of squares, if we have two values, the difference of two perfect squares, so a squared minus b squared, this factors to a plus b and a minus b. And just so you could see how this ends up working, I'll erase this just so we could have a little more room to solve the problem. A times a gives us a squared. A times -b gives us negative ab. B times a gives us positive ab. And b times -b gives us negative b squared. These two end up subtracting out because they're the exact same thing, just opposite. And that leaves us with our a squared minus b squared. So this is one way that we could factor it. Or actually, yeah, that's just one way that we could factor these values. And let's cut all of this. That's just one way we could factor those. I'm just a mess. Okay, there we go. That's one way that we could factor these. So let's factor these here. So our x squared minus 1. We could write this as x squared minus 1 squared because 1 times 1 gives us 1. And we could throw it into our difference of squares formula. A plus b, or in this case, x plus 1 and x minus 1. So now that we have that factored, we could come right back here and rewrite this equation. So we have 2 over x plus 1 minus 1 over x minus 1 is equal to 2x. We just factored that x squared plus, or x squared minus 1 to be x plus 1 and x minus 1. And now that we have that, it'll be really easy to find our LCD, our least common denominator. So from here, we need it to be divisible by x plus 1. So we're going to start with that. So x plus 1 divided by x plus 1. Those two divide out. So we're left with 1. We cleared all the fractions. And now looking at this, x minus 1. If we were to divide this by x minus 1, it doesn't divide. One thing we are not going to do is this and say, oh, it's just -1. We don't want to do that. We have like two completely different factors here. They are not the same whatsoever. So they're actually kind of opposite of each other. Not opposite as in opposite signs, just completely different from each other. So what we're going to do here for our LCD is multiply or find the product of those two. And that is what our LCD is going to end up being. So now this whole thing divided by this, we're dividing by x plus 1. Those two divide out, perfect. Divided by x minus 1. Those two divide out, no fractions, and divided by this whole thing, x plus 1 times x minus 1. And everything divides out perfectly. And there we go. So we found our LCD as x plus 1 times x minus 1. So that's what we're going to multiply to both sides and see what we end up getting. So 2 over x plus 1 minus 1 over x minus 1 is equal to x plus 1, x minus 1, with the numerator of 2x. And we're multiplying our LCD to both sides. X plus 1, x minus 1, x plus 1, x minus 1. So now when we multiply our LCD to this first fraction, x plus 1 and x plus 1 divide out. So we're left with 2 times x minus 1. And moving on to the next fraction, we have that minus sign. And now we have this fraction times our LCD. X minus 1 divides out with x minus 1. So we're left with x plus 1 times 1. So x plus 1 here. And that's equal to the right side. So over here, we're multiplying just one fraction on the right side. So x minus 1 divides out with x minus 1. X plus 1 divides out with x plus 1. And we're left with 2x. So now that we have that, we could start solving. We could simplify. So distribute the 2. So distribute this 2 to those two fractions there. So 2 times x gives us 2x. 2 times -1 gives us -2. And now this negative is going to be distributed to both terms here. So x times -1 is going to be a -x. Negative times 1 is going to give us a -1. That's equal to 2x. Let's combine like terms and see what we end up with. So 2 minus 1, I'm looking at the x's. 2x minus 1x is going to be just x. And we have -2 minus 1 gives us -3. And that's equal to 2x. So because the left side has a lot of stuff going on, we're going to make our right side our variable side. So we're going to move this one on over here. And to solve that, it's being held with that 3 with addition. So we're going to subtract x from both sides. -3 is equal to x. Or you could think of it as x is equal to -3. Let's make sure that it's not one of the parts that we excluded, because over here at the top, we stated the excluded values first. We said that x cannot equal -1 or 1. But down here, we have x is equal to -3. So we're okay, we're in the clear. We don't have what we call extraneous solutions. So solutions that seem to be true, but are not actually true to the equation. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.